Let's continue our discussion on logarithmic functions and equations. In this lesson, we're going to look at the correlation between exponential form and log form for equations. Since exponentials and logs are inverses of each other, we can rearrange one equation into an equivalent equation and possibly solve the original equation using the equivalent one. So we're going to practice changing first exponential form into log form and solving the variable. And then in the second part, we'll start with the log form and have to change it to the exponential form. For the first example, 2 to the power x equals 32. The base is 2, so that becomes the base of our log. The exponent is x, so for the log form, x will be our answer. X is the input for the exponential form. It will be the output for the log form. And then 32 is our output for the exponential form. So 32 will be the input for our log form. We can write sentences for each of these. The first one, 2 raised to the power x is 32, corresponds to the exponential form. X is the exponent of 2 that gives 32, corresponds to the log form. Remember that logs are exponents. Using tools that we've already discussed about solving exponential equations that are nice, which these are nice exponential equations, we should be able to write both sides with the same base. Let's use that information to solve for the variable x in this case. So 2 to the power x equals 32. Let's write down powers of 2. 2 to the first is 2. 2 squared is 4. 4 times 2 is 8. 2 to the fourth, 8 times 2 would give me 16. 2 to the fifth is 32. So I can write 32 as 2 to the fifth. If 2 to the power x equals 2 to the fifth, because I have the same base, my exponents must be equal. And I know that x must be 5. That also means that 5 is the answer to this log equation. Log base 2 of 32 is 5 because 2 to the fifth is 32. Try 3 to the power x equals 81 on your own. We'll take a look at 5 to the power x equals 125. 5 is my base, x is my input, 125 is my output. So when I rewrite into a log equation, log base of the old output equals the old input. We can write our sentence, 5 raised to the x power is 125, and x is the exponent of 5 that gives 125. To solve it, 5 to the power x equals 125. Let's look at powers of 5, since 5 is prime. 5 to the first is 5. 5 squared is 25. 5 to the third, 25 times 5 is 125. I need 5 to the third. So 5 to the power x equals 5 to the third, which means x equals 3, since my bases are the same. Since x equals 3, that also means that 3 is the answer to my log equation. Log base 5 of 125 is 3 because 5 to the third power equals 125. Let's look at 9 to the power x equals 27. 9 is my base, x is my input, 27 is my output. So I'll have a log equation with a base of 9. Logs always equal the exponent, so x will be on the other side of the equation, which means 27 needs to be the input for the log. Writing our sentence, 9 raised to the x power is 27, and x is the exponent of 9 that gives 27. In order to solve it, there isn't a perfect power of 9 that'll give us 27. So what we can do is see if there's something that 9 and 27 have in common. And they do. They have 3 in common. And sure enough, 3 squared is 9, and 3 to the third is 27. So I can use both of those in my equation. 9 is 3 squared. I don't want to forget that x for the exponent there. And then 3 to the third is 27. When we get exponents together, where we have an exponential expression raised to another power, like this is, we multiply the exponents. So 3 squared to the x power becomes 3 to the 2x power, and then we'll bring down that 3 to the third. We reviewed exponent rules in our radical expressions and equations chapter. We can write radical expressions as exponential expressions with rational exponents. We'll review the exponential rules again in our lesson on the properties of logs, since logs are exponents. So in this equation, we have the same basis of 3, which means our exponents must be equal. 2x equals 3, and we can solve for x by dividing by 2, and we get x equals 3 halves, or we could write it as 1.5, but for exponents it might be easier to keep it as 3 halves. So x equals 3 halves is our answer, and let's pull it back into our main problem. Log base 9 of 27 is 3 halves, because 9 to the 3 halves equals 27. And let's verify this. 9 to the 3 halves means we're going to take the square root of 9 and then cube it. Square root of 9 is 3, and 3 cubed is indeed 27. Now let's switch it around. Instead of being given the exponential form and we need to write the equivalent log form, now we're going to start with the log form and have to write the equivalent exponential form. To look at, I think I'm going to skip log base 3 of 27. You try that one, and we'll do log base 4 of 64 together. So here, log base 4 of 64 is x. This means, if I write the sentence, x is the exponent of 4 that gives 64. So x is the exponent of 4 that gives 64. Well, x is an exponent of 4, then that must mean 4 to the power x equals 64. Or that'll give us our other sentence. Now we can look at solving for x. 4 to the power x equals 64. I can look at powers of 4 to start. 4 squared is 16. 4 to the third, 16 times 4. If we can't do it right away, we just use our calculators. 16 times 4, hey, that's 64. So 4 to the third is 64. Since my bases are the same, my exponents are equal. X must equal 3. Pulling it back in, 3 equals log base 4 of 64, because 4 to the third power equals 64. You try log base 25 of 125 equals x. I will give you a hint that it should be a fraction, but see if you can get the answer for that one on your own. Let's do this last one together. 2 equals log base 10 of 10 to the 3t power. Notice here there is no base on that log. Since there is no base, it is understood that that base is 10. So if we write our equation, 2 is the exponent of 10. That gives 10 to the 3t power, whatever that is. So we can have 10 as our base, 2 is the exponent, and then this whole piece right here, 10 to the 3t, that's our answer on the other side. We can write our sentence, 10 raised to the power of 2 will give me 10 to the 3t. And solving it actually isn't too bad because I already have bases that are the same. So I just need to equate the exponents, solve for t. 2 equals 3t, so I can divide by 3, and t is 2/3. And we can definitely see this if we try to plug it back in. 2 equals log base 10 of 10 to the 3 2/3. Notice if we try to simplify, this 3 will cancel with the denominator and I get 10 squared there. And sure enough, 2 would be the exponent on 10. That would give me 10 squared. It works out. In our next lesson, we'll explore the graphs of logarithmic functions.